Okay, so in this video, I'm just going to quickly describe the process for um, topography lines from a digital file and uh, printing them in a way where you can use them to construct a physical topography model with. So what I have here is kind of quick site drawing project. This is classic called the roads, kind of traced out here a couple of the trees, and then obviously you can see topography lines. So my topography lines were generated from the 3D map that you see on our D2L course site. But however they were generated, this technique will work. And importantly, everything is 2D right now, so everything's kind of flat, same plane. Okay, so basically, what I'm going to do is I'll show you because we're going to kind of be doing this manually. I guess one of the things that's a benefit here is if you wanted to. So what I have here is a 1-foot contour line, but imagine you didn't have a 1-foot contour line, you had a 5-foot or a 10-foot or something. One of the things you can do is, depending on the thickness of your model, you can add contour, the thickness of the material that you're building your topo model. You can add or remove contour lines. And so, topographic relation or interpolation of topographic lines is a pretty straightforward technique, right? We're just kind of taking the average between two adjacent lines. But I wanted to just illustrate that that's quite a easy thing to do in Rhino. Well, using a command called tween curves. And so if I enter that command and I select two curves, you can see I can even set a number here. So let's say if I had 10-foot contour lines and I wanted one every 2 foot, I could actually enter 5 in there, and then I would get that would be 0, 2, 4, 6, 8, 10. So actually, you'd enter 4. Went from 10. They were 10-foot contour lines. You enter one less than the number of steps, basically. So we go from 0, 2, 4, 6, 10, so on and so forth. But anyway, so that'll automatically generate contour lines between two curves. Now you can see it will mess up a little bit. There's a couple ways we can deal with that. We can flip it for one thing. Okay, so yeah, we want to make sure that they're starting match at the same end to end. Like start, this curve is the same as the start of that curve. That's what that does. And I think the match method here will allow us to change it to sample points and then turn up the number of samples by 100, by 1,000. Yeah, so that'll also help us get a little bit better results sometimes. It's still not really doing great. So sometimes it might just be the geometry of your lines too. So for example, we could go tween curve. We just did 1. That's still not really doing a great job. So what we can do is kind of split it up places, and I would just do that by drawing a line where I'd want to split it. Go to the perpendicular point on the adjacent line. And you'll get a sense of where you want to split it during work, but take these two lines, split curves, oops, I draw them in whatever I'll show you with these lines. So take two contour lines, split. Just kind of split them where you need to. a better result. Go. There we go. And then you could kind of go segment by segment. Allows us to get slightly better. Anyway, so that's how you would add contour lines between needed more. But we have a good number here. I have 1 foot contours here. So, obviously if I'm building a model at 1/8 of an inch, I'm using a material that's 1/8 of an inch thick, etc. If I'm building a model at 1/8 of an inch and I have a 1/4 inch material, 1/4 inch cardboard or something, then I want 2 foot contours, right? So I would delete every other, or hide every other contour. So the best way to kind of frame this is to make a layout. So go to new layout. Now we can kind of determine whatever custom size we want if we just enter it down here. So I don't know, let's just imagine we're doing by 2 foot. Okay, there's my page size. Imagine that's kind of the base of my model. Way. Actually, you know what? I'm sorry, we should do that slightly differently. So I can adjust the layout here. I right click on it and I can go to properties. So I'm sorry, imagine I did have a 2 foot by 2 model that I wanted to make. What I'm going to need to do is actually print this layout. So I'm going to change it to an ArcD, which is 24 by 36. Adjust that one more time. Layout. Go to landscape. Okay, and then I'm going to make sure scale 1D. This is in fact 24 by 24. Oh, it is. Okay. So my detail view is 20. I get it wherever I need it on the page. Right. That's the size that my actual model will be. That's helpful. And then what I'm going to do is I'm going to change the scale of it to whatever scale I want to make my model at. If I say if I'm doing an 1/8 inch model, 1 inch on the page should be feet. Of course, this is assuming that my model space is accurate, which it is. So you should make sure that whatever you draw in model space is 1-to-1. Works properly. And the other thing I can do here is I can actually rotate my viewport. Well, there's a couple ways to do that. I can actually know if I can. You can't rotate the detail view. One way you could do it, probably the easiest way, really, would be to just rotate everything in your drawing. So huh, here's that my Rhino is not working properly. I'm going to go ahead and pause for just a second. Okay, we're back. So as I was saying, one of the ways that we can adjust the angle of our view here. I'm on my detail view. I can right click in there. I'm holding Control Shift on the keyboard. I'm right clicking and dragging. And if I do that while I hold Shift, it'll make it so I'm only rotating my view, tilting it. So I can kind of rotate my view until it's straight. Now that's not the most accurate way to do it. Eyeballing whether it's straight. So I could that. The other way I can do it, computer froze. This should just rotate everything in my model space. Straight up and down, that's easy. There we go, now I've oriented the house more the model. If I wanted to do that. And then the other way I could do it, one method would be to make a construction plan. So I typed in C-plane, and I'll just go 3-point. I'm going to orient myself to the house. And I believe in here I can go set view, plane up. The plane didn't get set. Try that one more time. C-plane, 3-point, house, set view, C-plane up. Here we go. That way you don't have to mess up your model. I'll rotate it. Right, and then we can do the same. So I'll just put the scale here. Maybe I'll play with a 1/4 inch. You guys, I think, are actually, well, making a big model. It'll probably be a 16. We're zooming out there, kind of enough to get a sense of change in the topography and how the house is situated. And, we can also go into the 1/2 inch scale. Really seeing quite a lot less. The 1/2 inch, obviously, our 1-foot contour would be 1/2 inch thick material. That's at one point where we're trying to kind of starting to make sense that that we would want to build the model, or I'm sorry, that we'd want to introduce more contour. Like I mentioned, I would just, especially since it's so zoomed in, like it's such a small area, I would just probably trim my contour lines, split the contour lines to the region where my model is, and then add more contour lines just to a small area. That. So I can take all my contour lines, split that, start making spin curves. However many more I wanted to add. Now, the other thing that you'll need to do, particular on the 32nd inch model, I'm sorry, the 16th inch model, obviously we're seeing a lot more context. Now, what I would do in order to leave a space to actually place the model of the house itself is I would just kind of trim away. I would just kind of trim away I would just trim away basically, so imagine this is a 3-dimensional topography and we want to situate like a model of the house. We need to leave a space in our topography for that to happen, right? I'm going to make a copy of the outline of our house, or actually, I don't even really need to do that. What I need to do is just trim those contour lines, right? Because as this contour line comes across, it's going to go back, right? And then meet itself again, leaving behind the outline of the house. And I'm going to do that for every single contour that intersects with the house. So what I can do is I can just take that house, trim, right? And then every time I cut out a contour, I'm just following that line until I meet back up with that contour. So that's going to leave a space basically at this level, at the level of this contour, for my house to go, get situated into the model. Now, the other thing is you may want to go deeper than that, right? We're talking about a larger model where we want to actually simulate the house being embedded in the earth, obviously all these contours would have to be trimmed away, but even when we cut out this layer, for example, we're leaving a hole the size of our house punched in that layer. I just wanted to kind of mention that it's important to keep in mind where those contour lines are going to go. I'm going to at least trim these guys for model. And then, so like I said, with the larger scale model, we'd probably be leaving a hole for the house even deeper. Okay. Now you also probably want to adjust the size of this, because we're going to want to show some of those little concrete pads that extend from the house. So I'll leave the cropping up to you. This is the other page size we can kind of print to easily, I should say. That's a 36 by 48. That gives us a little more flexibility. How big our model is, right? I'm just scaling the detail view. Say I wanted it 2.5 feet, 30 inches. Scaling 1D. Thirty by 30. So scale, basically whatever this rectangle is, that'll be the size of the model. Now the other thing that I want to actually cover here is obviously we could print this out and we could go through and kind of, basically what we're doing is we're cutting out this layer and we're cutting out this layer. Let's try and simulate that quickly so you can understand. Like we're kind of cutting like this. And then at the end of the day, we end up with a model where they're just stacked. And so what you could do is you could just print this drawing, right? And start at the bottom, kind of lay it over your material and cut that line, right? So the rectangle is layer 1, that line is layer 2, that line is layer 3. So each time I'm orienting my printout, my base, whatever material I'm using for my base, cutting out each subsequent layer, starting from the bottom and working my way up to the top. The other thing I could do, if I wanted to use less material to construct my base, is I can actually make 2 prints, and I can make them in alternate colors. So what does that mean? So I'm going to make a couple new layers here, and this is also demonstrated in the 3D tutorial. Reference that, but I'm going to call this my alternating Topo 1. Alternating Topo 2, and I'm going to make them different colors, red and blue. Okay, and then I'm just going to select every other Topo line. I'm going to put them on one layer. Select the alternate. Put them on the other. So what is that? Basically what this is I could lay this over a single sheet of material. So let's say I spray lam, use spray mount and laminate it on my piece of cardboard. Basically, with each print, I'm going to go, okay, I'm cutting along the red lines. This one, I'm just going to cut all the red lines. And what I'll have when I'm done with that is I'll have one set of overlapping contours. And I'm going to print this drawing twice. And then on the second time, I'm going to cut all the blue lines. And so basically what I'll end up with is like kind of an overlapping, which maybe I can try and draw that. So like, that becomes one cutout. And at the same time, I'm keeping this blue line in it. That's my score, or I'm scoring it, or keeping this blue line as a reference. Because when I cut out the next here, I'm cutting blue to blue, right? And I have the red line, so they're going to overlap each other by that much each new layer, right? So it's like I have a thin strip of cardboard overlapping a thin strip of cardboard, overlapping a thin strip of cardboard. So it'll kind of overlap like that and stack up just enough. It'll overlap just enough to kind of hold together. Obviously, we'll have to construct something underneath it to kind of hold all the layers of the material together. But that'll be enough to construct a base, and it'll use a lot less material than cutting the whole thing out of a sheet for each layer, right? Stacking it up solid. Anyway, so I hope that's kind of clear, and that's enough to follow that technique. And if there's anything not covered, we can unclear, we can talk about that as well in class. Go ahead and end it there.